All right, good morning, everyone. How you doing? Thanks for hanging out and staying on a Friday for the last few talks here. Let's go ahead and get started. All right. Look at all this. Isn't that amazing? We've got scheduling, orchestration, service discovery, service management, networking. It is absolutely amazing what all of you have accomplished. Super impressed. But let's get rid of this because this is the serverless talk, and we don't want to see that stuff anymore. Just kidding. The serverless community is really standing on the shoulders of giants. I don't think any of us in the community would be here without all of you. I think that the fact that serverless is a thing is really a sign of your success, and that's awesome. Anyway, this is the serverless and event-driven future. In this talk, we're going to chat about the future of serverless. We're going to talk about what the CNCF is doing to enable that. And we're going to make it real by attempting what might be one of the most ambitious demos of all time. I don't know if you all saw the tweet I posted earlier, but it's a lot of moving parts, a lot of different parties involved. It might be suicide. I'm Austen Collins. I made a popular open source tool called the Serverless Framework in 2015. It helps you build applications exclusively on AWS Lambda, Azure Functions, Google Cloud Functions, and other serverless services. I work as the CEO of a company called Serverless Inc, which I founded, but really I'm just a developer. I love to make things. I like to make solutions, applications, meaning in the world. I didn't become a developer because I wanted to do distributed tracing. I didn't become a developer because I needed a NoSQL database. I didn't become a developer because I wanted to do scheduling and orchestration. I became a developer because I wanted to make great things. And I really love tools that help me stay focused on making great things. I've been joined by a fantastic group of people at Serverless Inc, where we're all trying to make tools to help everybody stay focused on delivering results and making things. And we're not alone. Because a couple of years ago, out of left field, suddenly came this serverless trend. I don't think anyone was really expecting it at the time. It was a cultural awakening. A massive amount of people cried out and said, you know what? Software is essential to solving humanity's problems. We need software more than ever before, but it still feels too complicated to make. Can we get rid of some of this complicated stuff? And we've seen this desire toward higher order abstractions before in so many iterations, from cloud to virtualization to containers to platforms as a service, and now to managed functions and serverless services in general. Serverless isn't a new thing. It's not a different thing. It's just the next chapter in the same old story towards simplicity, where we identified a new level of abstraction with some new qualities that we really like. And these qualities are functions are the unit of deployment and the unit of scale. And these things should scale fast, scale quickly, and scale automatically for you. You shouldn't have to think about that. And of course, you should never have to pay for idle. You shouldn't pay for any resources that you aren't using. There shouldn't be a scenario where you have to over-provision resources anymore, or you have underutilized resources. Current trends. Here's kind of what's going on in the serverless world as of right now. This whole story got started with closed source serverless platforms, particularly AWS Lambda, led the charge in late 2014 when it was released. It was followed by Azure Functions, Google Cloud Functions, IBM Cloud Functions, and now, today, every single public cloud provider has their own functions as a service serverless compute option. And it's pretty cool. These things are great for low overhead, ease, speed, convenience, and these are kind of the most pure serverless experience out there. On a parallel path are the open source serverless compute platforms. And these are platforms that are building a serverless experience on top of Kubernetes and containers mostly, like Kubeless, Apache, OpenWhisk, Oracle FN, Fission, OpenFAS, a lot of fantastic projects here, and these give you that total control back. There's still a lot of speed and ease, but you do have the ops burden here. Now, the way you'd use something like this is you have someone maintaining the serverless platform in your organization and exposing kind of the higher level stuff to the developer teams. But both of these trends, the closed source serverless platforms and the open source serverless platforms, they're both seeking to offer this same serverless experience and to create something called the serverless application. And this is an entire application architected as functions and events that also might use some other serverless services like DynamoDB or AWS S3, for example. And there's a lot of shapes and forms of serverless applications out there, but these are the most common traits. And the use cases that we see predominantly from the perspective of the serverless framework our data processing pipelines, backends, APIs, event-driven workflows, and just a whole bunch of other cool creative stuff like chatbots and voice bots and all types of neat automation. I think this is what happens when you reduce overhead and complexity generally. You liberate a lot of productivity, you liberate a lot of creativity, and that's what we see in the serverless community. Now, why is this popular? Developers love this experience. Functions and events are really easy to reason about. It's accessible, it's flexible, it checks a lot of the boxes, it's also distributed. And now, if you want to move fast, if you want to reduce overhead, if you want to increase the rate of innovation at your organization, if those are your goals, this is now like the best option in town. And we see fantastic results with serverless applications almost every single day. Forecasts, where's this stuff going? What's next? That's kind of what has happened. Here's where we think it might be going. First off, serverless is a story of functions and events. And events have been around for a long time. Event-driven design has been around for a long time. But we think events are going to be especially prevalent in the future, probably more events than ever. And this is because of IoT. Is a good reason for this. There's going to be IoT devices everywhere, sensors everywhere, tracking our movements, tracking every single thing that happens. And we're building intelligent systems now, systems that can analyze events and make decisions on their own in real time. And also integrations between your services, your microservices, your legacy, your new stuff, integrations across your stuff and all the third-party vendors that you're doing. Integrations are generally increasing. And serverless compute, aka event-driven compute, as it was originally called when AWS Lambda came out. Serverless compute, with that, it's never been easier to react to something that happens with code. Right? I could upload 1,000 functions right now to AWS Lambda. It's not going to charge me anything until something happens and it triggers those functions. And when that does happen, it's going to scale. So anyway, a lot of this stuff is going to create this habitat we think that is just ripe for a lot of events, a lot of event-driven design. And I don't know how to generally describe this other than to say I think the digital world is kind of storming into our human reality. And it's going to be increasingly event-driven because that's how humans operate. That's how businesses operate. So what follows after this? Functions everywhere, we think. We have events, you have a lot of events, more events than ever. We have the proliferation of serverless computing platforms, which offer this fantastic, easy experience for reacting to events, and use cases that require computing close to the event source. And we think this will bring about this scenario of functions everywhere. So functions running across cloud providers, whether in those kind of proprietary services or in containers. Functions running on-prem using one of these great open source serverless compute platforms. Functions running in the edge. So in general, this is kind of what we think the future looks like. How the applications kind of combine all these things to produce outcomes, that's still kind of unknown, but we do think that this is where things are heading. So more events, functions everywhere. And the next question is, what does the CNCF do amidst all this? If this is where we think things are going, what is the CNCF's role in this world? And here's what we think it is. Standards. Except I'm not supposed to say standards because the CNCF is allergic to that word, so I should have crossed it out. Harmonize, common specifications, stuff like that. You know what I'm trying to say here. So you know, why is this important? Because in this world where there's events everywhere and functions everywhere, developers just want a single experience for doing things. They want a single way to deploy their function anywhere they need to deploy it. And a single experience for reacting to the event data that's coming into that function. If we could do that, we could solve a lot of problems and make developers happy and achieve this future. Developers shouldn't have to think about the quirks of a platform. Right now, if you want to write a function on AWS Lambda or Google Cloud Functions or maybe some of the open source serverless platforms, the function signatures look different. Event data that's coming into them all looks different. So anyway, there's a lot of problems here, and the next question is, what do we standardize? Harmonize. What are we going to approach first? Here's where we see a lot of disorder in serverless architectures. Runtimes, even though a lot of the providers offer the same runtime, they have a lot of quirks, a lot of differences still. They might include some different environment variables, incorporate libraries that are preloaded already. APIs, again, the function signature problem is a great example of this. The function that you write for Lambda is not the same as the function you might write for Azure Functions. Events, everybody's publishing events, but all the event data looks totally different. If you want to find what the event title is, if you want to find what the event version is, it's all in different types of properties. Nobody's agreed to like a consistent format. Even Amazon publishes different formatted events from different services. So they couldn't even agree on a single event format. And then plumbing. How does this stuff get wired together? How do we actually create an event-driven workflow where something triggers something else, an event is transmitted, and a function reacts? I think the CNCF in particular is a great neutral ground to work on these. And the Serverless Working Group, which has been established in the CNCF, has been focused on doing this since January of this year. And it turns out events were an uncontroversial starting point. And we had some interest by key industry stakeholders, and so we decided to start there. And again, events are super important. Serverless is a story of functions and events. We think that there are going to be more events than ever. And ultimately, yeah, you can move your containers and your functions around. If you can achieve that, that's fantastic. But what are you going to do about that data? It's your data that gets stuck and creates a lot of lock-in. So the Serverless Working Group got together, and we decided to create a specification for describing event data in a common way, and that is cloud events. Cloud events is a standardized transport-neutral definition of the structure of metadata, structure and metadata of events. Basically, it's an envelope. It wraps around your event data. It describes what's in it, what's in the event, and more details like where it's going, where it has been, so that publishers of events, middleware, and subscribers can all consistently rely on these properties to understand how to better process, route, version, govern event data. This is 3 weeks ago, we introduced version 1 of Cloud Events, and version 0.1, sorry, very, very early, obviously. It's been in the works since November of 2017. Here's a JSON representation of Cloud Events, and although JSON is not required to use Cloud Events, this is just a representation of it in JSON. And it's got a lot of great features. Again, this is a 0.1 version. It's very early. But there's already a lot of good stuff in here. Like just consistency in properties alone is a great achievement. But first off, we have event type, of course. And you can see the format that we're kind of converging on here. Now these should be prefixed with a reverse DNS name, which is pretty cool. So a lot of companies have TLDs for their companies. So this actually works in that model. There's an event type version. This enables kind of interpretation of events better by eventual consumers. And better evolution of event data. That's always a huge problem in event-driven design, is how do you evolve that data as it changes and grows. Cloud Events version was essential to making sure that this whole effort was agile and could be updated as we continue to add stuff and hopefully not introduce any breaking changes, but it could happen. Source, there's a URI. This describes the event producer. This will include information such as the event source, the organization publishing the event, and some unique identifiers. But the exact kind of semantics and syntax is up to the event producer. There's the event ID, pretty self-explanatory. There's an event time, pretty self-explanatory. There's a schema URL, which is a link to the schema that the data attribute adheres to. And there's an extensions property. Extensions was just basically kind of this catch-all property where we thought, we don't know what people are going to want to do with this yet. Let's see if we could just put in a way into this event format where people can stick their custom properties, and let's see if we can kind of identify some common patterns from that. And if we see anything that's becoming increasingly popular, we'll consider promoting it to be a first-class event property. And lastly, data. So all this is the envelope. This is what we call the context. And this ships consistently with all your events, and the data is where you actually include kind of the custom information about what happened. It could include state of what changed, or it could just include a place or a link where you can go and get information about what happened. And that's it. It's very simple. This is a pretty small effort in scope that I think has a lot of big ambitions. So use cases. What can we do with this thing? First off, normalizing events across environments. I talked about this problem earlier. Not even Amazon can agree what type of event format it should use. So that would be great alone. So now developers, whenever they're going to write their functions, they don't have to think about the different shapes of data that's coming into those functions. Facilitating integrations across platforms. Integrations are everywhere. We're integrating a lot of legacy stuff with the new stuff. And these integrations are increasingly event-driven. However, there's no kind of common way to define those. So this can help out a lot with that. Increasing portability of functions as a service. Now, if you write a function that expects one type of schema, theoretically, it's a bit more portable than it was when it expected a different type of schema. Normalizing webhooks. Webhooks, it's a common event-driven pattern that's been around for a long time. It's come a long way without being standardized. But we think this could do a lot for webhooks. Event data evolution, we talked about that. Event tracing, being able to trace events, where they came from, where they're going, to create more sophisticated workflows and solve that notorious observability problem that's there with event-driven design. The future looks pretty awesome if you like to build things and you want to be productive. I mean, we could provision all these functions, we could have them reacting to events, we can create incredible workflows and stuff, but how do you actually understand what's going on and observe all that? So I think this simple format can help a lot with that. What's next for this? We have the JSON event format that I just showed off. That hasn't actually been added, I think, to the spec. There's HTTP bindings that we're going to add in. There's MQTT 3.1.1 and 5.0 transport bindings, AMQP 1.0 transport binding, and a webhook specification specifically for cloud events. So we want to make sure that this thing integrates into the ecosystem and a lot of protocols and transports that people are using already. And the most fantastic thing about this is we haven't even publicized this effort. But a whole bunch of people jumped on board. I think they recognize the potential of this small little thing that we're doing here. And we have fantastic individuals from the Serverless Working Group working on this from all types of different companies. There's myself, there's Sarah from Google, Clemens from Microsoft, Doug from IBM. Doug's running the show. He's trying to bring order to those meetings that we have. He's somewhat successful. There's Kathy from Huawei, Chad from Oracle, a whole bunch of fantastic people. And we've been working together on this for a few months now, and we've come a long way. So let's jump into it. We talked about what this thing is, kind of how it came about, and how maybe it could help out this future that we're expecting. But let's actually see if we could do a demo of that and make it real. So everybody in the working group has been working for a long time on this demo. It's a big collaborative effort. And it's certainly ambitious. Again, it involves a whole bunch of moving parts. We're going to keep our fingers crossed here. I'd pray to the demo gods, but honestly, if this thing works, I think I'm going to become a demo god. This is the path to divinity right here. All right, let's explain what's going on. So first off, we wanted to show off interoperability because that's a big mission of cloud events, right? We're taking data and we're giving it a common format. And when it has this common format, a whole bunch of different subscribers know what to expect. So theoretically, it could be transported across environments a lot more easily. It's more portable, it's more liquid. So we wanted to show off an interoperability demo. And this is the scenario that we decided to come up with. It starts off with one publisher. That's AWS, and what's going to happen in the demo is I'm going to upload an image to AWS S3. AWS S3 is going to send out an event, and it's a native AWS event, and that event is going to go to a Lambda function. In that Lambda function, that event, that native S3 event, is going to be converted to a cloud event. It's going to be transformed to a cloud event because obviously we're just getting started. AWS doesn't support this format natively. That's that might be a ways out there, but there's an easy way, thanks to serverless compute, to actually modify this thing and start using the format right away. So that S3 event is transformed to an S3 cloud event, which is then sent over to something called the event gateway. And this is a super awesome event router that my company makes. And it's basically kind of what we think is the event router of the serverless era. You could take any type of event data, throw it at it, and it'll route it to AWS Lambda, Azure functions, Google Cloud functions, Kubeless, any place where there's a serverless function. I think you might have seen Kelsey Hightower show this off on Wednesday. He did a quick keynote presentation on it. And what the event gateway is going to do is it's going to take that event, that S3 event, which talks about an image that was just uploaded. It's going to send it over to a Google Cloud function. And the Google Cloud function is going to do something with it. But actually, it's not just going to send it out to a Google Cloud function. It's going to send it out to an IBM Cloud function as well. But at the same time, it's also going to send it out to an Azure function, an SAP Kubeless function, 4 functions now. But we wanted to stretch the limits a bit further. So we also added a Nucleo function, an awesome open source serverless platform, a VMware dispatch function, another open source platform, Oracle FN function, another open source platform, and the Huawei function. And we said, why stop there? We could add more. So we added on a Red Hat OpenWhisk, running on OpenShift function, an AWS Lambda function, and an Alibaba Cloud function. Okay. So the S3 event goes into the gateway, it gets transformed to a cloud event, goes in the gateway, and via this pub sub pattern is broadcasted to all these functions. Now all these functions get an event that says, hey, this object was uploaded to S3, and it's up to these functions to go then grab the image from the S3 bucket and do something interesting with it. And so we left it up to these providers because, get this, every single one of these providers, almost every single one of these providers, built the function themselves. And we said, you know what, go do something interesting with the photo. A lot of the functions, a lot of the providers decided to do image analysis on the photos. So as a cool bonus of this demo, you're going to see how about like 7 image recognition technologies compare against the same image. And then we thought, okay, how do we make this observable for an audience? What are we going to use for this? So we realized we needed some type of log to output all the results in a nice centralized place, and we needed some incredibly killer technology to make this awesome. And so we used Twitter. But why stop there? What if we brought in another event source? Azure Storage. And what if we also uploaded an image to Azure Blob Storage and all of a sudden had an Azure Blob Storage cloud event, which was then sent over to Azure's Event Grid, also another amazing event router built into the Azure platform. And Azure Event Grid then sends out that Azure Storage event in a pub sub pattern and also sends it to all these functions. So every single person who wrote a function to integrate into this demo wrote the function to react to the AWS S3 cloud event and the Azure Storage cloud event. And cloud events made that a lot easier. Again, consistency in that event data. And again, so all that's coming from AWS S3, all the event that's coming from Azure Storage and being processed by all these functions, all of this is going to be dumped into Twitter, if it works. So let's go ahead and give this a shot. I'm going to try and switch up my setting here. I didn't anticipate not having some other screen to look at. So let's see. I'm gonna mirror my screen. Okay. So far, so good. First part of the demo successful. Let's go ahead and set things up just a little bit better here. Okay, so first off, we're going to start off with Azure, the Azure event, actually. I have the Azure CLI installed, and we've got some images here. The first thing we're going to send out is a cat photo, and I already have the command written in here. This command is going to upload this cat photo that's local, that's on my local system here, up to Azure Storage, and it's going to go through that whole sequence that I just described. So the upload happened. Here's a little kitty. It's a cross-eyed kitty, but it was in the public domain, so I thought, oh yeah, well, that'll work. And let's see how this shapes up. Okay, so here is our Twitter feed. There's some test stuff going on in here already, and I'm going to go ahead and try and refresh this and keep my fingers crossed, and we'll see what these functions have done with the cat photo. Okay, we have Google. I'm going to refresh just a couple times here, just to make sure we get all the events in there. Okay, number one, we have Google. Google took the image, processed it, and they said, "I see a kitten with crossed eyes." That's amazing. That's really well done. Next up, we have the FN project, which is also doing some image analysis. And it just says cat. That's good enough. We have a Red Hat OpenWhisp function running on OpenShift. This just simply dumped it into the Twitter feed, worked flawlessly. Dispatch then went and put on a watermark, their own logo, onto the cat photo. So there's your new mascot. And IBM Cloud Function used Watson to analyze this, and Watson thinks this is a picture of a kitten. Well done. Huawei Cloud Function simply dumped it into the log here, worked flawlessly. AWS Lambda Function scanned the image and used AWS recognition and came up with this is an animal, cat, and kitten. Well done, AWS recognition. Here's Azure, an Azure function which used the Azure image analysis technology. A white cat with its mouth open. It doesn't have its mouth open, but there's some white in there, so that's pretty good. I'll still give it to you. The Cubeless is using SAP Leonardo and thinks this might be an Egyptian cat. All right, and Nucleo is only 41% confident saying this, but it thinks it might be a Siamese cat. All right, so pretty good, right? Pretty awesome. We literally just kind of broke down some barriers. Thank you. But, you know, yeah, we broke down the barriers between clouds and did a pretty awesome interoperability demo. I want to just push the limits here a little bit further. Let's just try out another image real quick. This image was taken by one of our main contributors, Clemens. He's a fantastic photographer. This is an image of a scooter. I'm going to upload it to Azure Storage. Again, that event is going to be sent out through Azure Event Grid, and we're going to analyze it. Here's the scooter. Again, Clemens, I forgot to give you credit here, but you know, but it's looking pretty sweet. All right, so let's give this a few seconds here. We got 9 new tweets. That looks pretty good. Let's give it a shot. Let's see what these functions have done. All right, FN project says motorcycle on the outer box here, but unfortunately it says handbag on the inner box. Oh, well, that's half right, half right. VMware, dispatch, watermarked this flawlessly. Huawei function dumped it in here flawlessly. Google sees a car. Oh, not quite. Watson thinks this is a laser-guided bomb. So distrustful, Watson. Azure says a stack of flyers on a table. But wait a minute, there might be a stack of flyers on the table in the background there, so maybe we'll give it to him. SAP Leonardo thinks this might be a motor scooter. Nice job. The OpenWhisp function dumped it in here flawlessly. AWS recognition thinks this is a picture of a motor scooter, motorcycle, transportation. All of this worked out fairly well. Not as good as last time, but pretty cool. All right, that was the Azure flow. Let's do the same thing with AWS S3. And to do this, I'm simply just going to take another image and I'm going to dump it into the UI here of my S3 bucket. And I'm going to upload a very important picture of a spaceman, but not just any spaceman. This is one of the first men on the moon. It's Buzz Aldrin taken by Neil Armstrong. And hopefully, if any of these AIs want to become citizens of America one day, they better understand what's going on in this photo. Anyway, so we uploaded this to S3. Again, S3 emitted a native S3 event. That went to a Lambda function. That Lambda function transformed it to an to a cloud event. And that was sent out through our event gateway and broadcast out to all these functions. Pretty awesome. And we've got new tweets piling in. I'm just going to refresh a couple times, make sure that all of these have had time to process. And we got a sneak preview. Okay, that looks pretty good. Oh, we have Alibaba in the house. Awesome. All right, let's start with this Alibaba. I think they all came in. Alibaba image recognition. This is Alibaba Cloud Function, by the way. Thinks this is a picture of something in Chinese that contains something else in Chinese. So I ran this through Google Translate. According to Google Translate, this means dog, and this means shovel. So Anyway, okay, credit for trying. Okay, dispatch, watermarked flawlessly. Huawei dumped it in here flawlessly. FN project, person, okay, give it to you. It's a strange looking person at that. But teddy bear, I don't know about that. That would be one scary teddy bear to give to a kid. Open WISP function by Red Hat, dumped it in here flawlessly. AWS recognition thinks this is an astronaut, human person, pretty good. AWS recognition. Nucleo says this is a gas mask. Only 48% sure though, so. Watson says this is a picture of an astronaut. Well done, Watson. Nice job there. SAP Leonardo says this might be a snorkel, or there's a snorkel in here somewhere. Google says I see the landmark Arches National Park. Okay, and Azure Cloud, Azure Function, a person riding a bike down a dirt road. Oh, these are hilarious classifications. I should stop there, we're running out of time, but we have just one more bonus and then we'll wrap it up here real quick. We're going to help somebody realize their dream today. This person wants to be the most cloud-native person in the world. His name is Dan Kahn. He's the executive director of the CNCF. And we're going to make that dream happen today. We're going to send Dan Kahn up to the cloud and have him be distributed across every single cloud platform out there. So let's just do this and make Dan fulfill his inevitable destiny here. So I'm uploading Dan's picture to S3, going to do the same flow, and the upload completed. Here's what we're looking at, Dan Kahn, but we added some sunglasses because when you're going to be the most cloud native person in the world, you got to look fly. So he's got some sweet shades on, and let's just see what the results are in here. I don't know if Dan's out there, but hopefully he watches this and appreciates it. Okay. The functions are reporting. We see some sneak peeks in here. Results are looking pretty good, actually. We've got the Red Hat the Huawei function. Dropped it in here flawlessly. I know what FN is doing here, so I'm going to skip that real quick. The Red Hat Open WISP function, just dumped it in here, worked well. AWS recognition thinks this is a picture of human, people, person. Well done. Keep it general, that's safe. Alibaba says it's a picture of something in Chinese that contains something in Chinese. I looked it up, it's character that contains sunglasses. So that's pretty good, nice job Alibaba. Nucleo found sunglasses, 94% sure it did, it's fantastic. Watson says this is this picture of a myope, not sure how to pronounce that, person with glasses, which, yeah, pretty good Watson, well done. And SAP Leonardo says there might be sunglasses, dark glasses, shades. Google says, I see Dan Kahn. And he looks joyful. Of course he does. He's the most cloud-native person ever now. And Azure says, a man wearing glasses and smiling at the camera. That's pretty darn good, I gotta say. Let's just see what that FN project did real quick. Oh no. They thug-lifed him. Oh, that's pretty good. Nice work there. Anyway, Dan Kahn has never been more cloud native than he is today. So, all right, just to get through this, only got a couple minutes left. Future, where's this stuff going? We have a lot of ideas to add to cloud events on tracing to help enable that. Workflows, make more sophisticated event-driven workflows. Correlation so that you could identify groups of events via tags or labels. So you could do larger processing. Rules, so you could identify where this event should go, where it should not go. Standard events, we think this might be a good opportunity to start creating some type of registry or something of common events. And in this example that we just showed, it kind of prompted this idea of like, oh, what if we just made an abstract event that was almost like this object created event that worked across different storage platforms. That's something that's interesting to look into. And just a cool event directory overall. Again, we have almost these universally unique event types in the format. What could this lead to? Maybe a directory of all events on the internet one day, who knows? And webhooks, better support for webhooks in general. So anyway, all this stuff is cool. It's very kind of bleeding edge and neat, but how do you actually use this today? What can you do with it? Actually, you saw all the people working on this. There's a lot of support for this event format, and these companies are moving aggressively fast, even the big companies. They're moving at startup pace. It's awesome. So I do have a couple announcements here today, first of which is Azure Event Grid now has first-class support for cloud events, already built in. It's amazing. Support for all Azure platform events, and it's available today in production. And it looks like you could even send custom cloud events into it. And it's in 3 regions, 3 data centers right now, and it's going to be rolled out globally next week. That's pretty awesome. You can start using cloud events today with Azure. Incredibly innovative and fast-moving company. Super cool. Up next, we just launched our hosted event gateway. We also have an offering for this. And again, it's very focused on the multi-cloud scenario and works very well with Lambda. We have a lot of close integrations with a lot of other Lambda services. So you can integrate with Lambda, you can integrate directly into Kinesis or Redshift and Azure Functions, and we have a lot more plans for this. But this is, the event gateway uses cloud events by default. That is its default format. It's completely open source. You saw Kelsey deploy it a couple days ago, and it integrates with our serverless framework. You know, our serverless framework provides that great application experience where you have a configuration file that lists functions, and each function you just write the events that trigger that function. The framework will go provision all the infrastructure you need, upload your business logic on top of that, and wire it up so that it works together. But you've always been limited to platform events, like all the events on AWS, for example. But now with the event gateway and its support in the framework, you can put in all types of custom events in there and literally get closer to reacting to anything easily with code. So if you want to check it out, serverless.com/event gateway. And that's a wrap. If you're interested in cloud events, check out cloudevents.io. There's github.com/cloud events, which has contribution information. We meet every Thursday at 9 a.m. We do a call then. If you want to chat with me, I'm Austen Collins on Twitter. And I just want to give a round of applause. Thanks to the CNCF, but especially the Serverless Working Group, the people in these front rows who made it happen.